In this video, we're going to apply the concept of simplifying radicals to monomials. Remember that monomials are, they're polynomials with one term, like the radicand in this expression, for example. Just a product of a real number and or variables to some power or powers. So the things to keep in mind in a monomial is that we're still going to use a factor tree for the coefficient. But you know, the thing about if you've got a variable to a power, it's just that variable that many times multiplied together. So we'll use that idea. The thing that might be the trickiest part of this to me is that I have to remember that radicals can only output positive values. So since I don't know what value a certain variable might have, it's better to write a pulled out variable, if you will, out of the radical with an absolute value around it to be as mathematically correct as we can be. Let me show you an example of how this works. If I work with the square root of 32x cubed, I'm still going to make a factor tree for my coefficient, my 32. We actually did this on the previous video, but I'll break this one down a different way. I'll go 16 and 2. I'll call 16 8 and 2. And then we'll do 4 and 2. There are actually a ton of different ways to break this down. And 4 is 2 and 2. So either way you slice it, I've got that 32 is the same as 2 times 2 times 2, or 2 to the 5th. So there's my factor tree for 32. So let me try writing out what I've got a prime factorization for this radicand, if you will. 32 can be written as 2 times 2 times 2 times 2 times 2. And I've got x cubed, but x cubed would just be x times x times x. So in a sense, there's a prime factorization for this monomial. And when it comes down to looking for pairs, well, there's a pair, there's another pair of 2's, and there's a pair of x's I can bring out. So what comes out? Well, I've got a 2 for that group of 2. I've got a 2 for that pair of 2. Now with this x, this gets back to the second point we made up here. This should represent an x outside the radical. But I don't know if x was positive or negative. And the absolute value, or excuse me, the square root of some number can only be positive. I need to put absolute value around that to indicate that I don't know if x was positive or negative, but what came out has to be a positive number. Now, the things that are left on the radical are a 2 and an x. And again, just like previously, I don't want to leave that in my answer. 2 times 2 is 4. 4 times the absolute value of x times the square root of 2x. And we're done. We've simplified that radical. There we go. Here's another one to look at. We've got 98, a to the 5th, b to the 4th, c cubed, and we want the square root of that. So I'll start with a factor tree on 98. You know, I happen to know that that's 49 times 2. And 49 can be broken down into 7 times 7, and 7's prime. So what do I have? Well, I've got 7 times 7 times 2. I'm going to try not writing out all the variables this time, but I've got a to the 5th, b to the 4th, and c cubed. So we're to the point where I'm going to ask what can come out. Well, a 7 for sure. I can get a 7. I can't get this 2, he's stuck. a to the fifth, maybe I will write these out this time. A to the fifth is a times a times a times a times a. So just from a to the fifth, I think I can get a times a out, which would be a squared. For my b's, this b to the fourth is b times b times b times b. I can get 2 pair out of there as well. It would be b times b. It's b squared. And notice I'm putting absolute value around all the variable things. We'll talk in a second about whether or not I need to keep some of those. C cubed is c times c times c. I think I can get 1 c out, but I'm going to be left with 1 as well. So out comes 1c. And what's left under the radical? I've got my 2, I've got my a, and I've got my c. 2ac. Now, this guy here, absolute value of a squared and absolute value of b squared, I can drop the absolute value there because any value a might have, if I square that, I'm either going to get 0 if a was 0, but I'm going to get a positive value for this, whether a was positive or negative. So if these are, second power or fourth power or any even power, then absolute value is redundant. So you can drop absolute value. And I'd like to see you do that. So the best answer here would be 7a squared b squared. I can't drop the absolute value around the c because it's an odd power. It's like c to the first, And then I should do square root of 2ac. And there is the best simplified answer. Let's do one more. We've got 81 m to the fourth n to the eighth p squared. I'm going to break down 81 in a factor tree. 9 and 9, actually it's a perfect square, isn't it? I'm wasting my time. I know where this one's going to end up. But it is the same as 3 to the fourth power. So what do I have? Well, I've got 3 times 3 times 3 times 3 times m to the fourth times n to the eighth times p squared. I am going to do this one without writing out each variable to the power. Well, what comes out? I've got 2 sets of 3's, so I can bring out 1 3 for each of those. 3 times 3. M to the fourth would be like m times m times m times m. So I've got absolute value of m squared. N to the eighth would be like n times 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 n. So I could make 4 groups of 2 out of that. I need n to the fourth with nothing left. And p squared is like p times p. I could get absolute value of p out. 1 for every 2. Hey, everything came out of the radical. And if that happens, that's okay. I just don't have any radical left. Everything came out. This was actually a perfect square. Now I should simplify this. What do I have? Well, 3 times 3 is 9. I don't need the absolute value around m squared because it's an even power. I don't even need absolute value around n to the fourth. That's an even power also. But p is an odd power, so let's keep it around him. And there's my simplified answer. The square root of 81 m to the fourth n to the eighth p squared is 9 m squared n to the fourth times the absolute value of p.